they know enough now, so they don't really care to stay through the whole thing. And I'll go a little faster, but I want to give you an outline for the report. Okay. I think we'll just make this blank. Layout. I want layout. Yep. Okay. Let's think about EORM report. Now remember, our goal in any report is to be short and sweet. Okay. So the title should be something, and then also I may have said to you, scientific reports are supposed to be terse, meaning a small number of words if possible, terse and dry. So you don't want to, you want to use not quite formal, but you want it to not sound too personal. Like we report on a measurement of such and such, and not go, well, yeah, we did this measurement of E over M, and see the difference. So this is sort of like a measurement. A title could be a measurement of E over M of an electron, of electrons, say, or a electron. And so you say we report the results of a measurement we made, and duplicating the famous J.J. Thomson. Now, you do not write up all that spiel. Do not write up, like, how do we know they're electron business, right? Remember that? That was last week. You don't put that into the write-up. So what you did is we prepared a beam of electrons with a known speed and placed them into a uniform B field. And measured the radius of curvature of the beam path. The beam path was a circle. Well, let's see. Yeah, we could maybe reword it a little bit differently. So then you're going to go on to say, first of all, how did you create this beam? And of course, you're not writing this question. And so you have, remember, there's an accelerating voltage. And of course, we need a source of electrons. We went over all this last week. And there's this concept of collimation. So you say, first we will describe the experiment itself, and then we will describe the data taking technique where so you say, first the experimental apparatus, and then the data taking technique with what data you took. And so you say we had, what was it, the constant current and V and R, and the constant voltage and I and R. And then let's see, how does the flow go here? We produce these two tables, and then and then you describe the you described the creation of the two equations. What was it? V equals something times R squared, and then I equals something times 1 over R. Why you did this? Because remember you had the F equals Q VB also equals MV squared over R. And also Q times V equals kinetic energy, which equals 1/2 mv squared. And you did this because you arranged it this way because you wanted to do a straight line fit. So remember now, you create the beam. Then you have how is the B field created? And for example, um, how do you know how fast they're going? How is the B field created? Then how do you know what the B is? Well, we have that K, and you don't have to derive that. You just say we were given K. And then why will they travel in a circle? So that is sort of, right? So this is the apparatus. And even this is too, but this is sort of now you start bringing in the QVB. Then you're moving over to, from here, this is now going into 2, the data taking. You did these 2 things. And the reason we're doing that is just because we want to produce two independent E over M determinations. Well, quasi-independent, but it's a double check. The reason, and I haven't gotten into it too much, we do it 2 different ways because if we got 2 really badly different answers, we would wonder if something was wrong with our apparatus. But I'm not holding you guys as 1,200 students. I would expect the 2,200 students to explain, to get into that. Then, yeah, then the derivation here, and then new slide. Then you go into the fitting process that we just went over. And remember, there's a recording of it online. There's also, I have playlists at the top of my channel about all about chi-square fits as well. And so this is where you say, we had the table. For example, we had R plus minus R. So then we calculated R squared plus minus R squared. Then we had the fit line, et cetera, et cetera. And we got, using the sum of the residual squared, we got a value of the slope equals to this. And then we plugged it into the equation we derived earlier and got a value for E over M. And yeah, that's pretty much it. I mean, then you say, I'm wondering about the chi-squared, and that's a lot of, well, let's think about this. So, right now, remember, you don't have to go into a huge discussion. You just say, look, we created all these, the slope, the y-intercept, and then we did sum of the residual squared. And we used the solver built into Excel to minimize some residual square for us. And then we constructed a chi-square, which is just the residual squared divided by the error squared. And don't worry about the you could just say we calculated a plus minus V for each point. Can keep it simple. And then so we did chi-square of residual squared divided by the plus minus V squared for each point. That's it. And then we let solver minimize it for us again. And then to get our plus minus slope, we let solver, and the plus minus slope is defined as plus minus is chi-squared plus 1, not plus minus. There's no such thing. And so then we ended up with a slope like this, and that translates into a plus minus on the E over M, and we get, it's very nice. We got so much percent here, which compares favorably with the percent error. And I think, let's see. So, well, you'll have the weekend. If this is bogging you down, you let me know, and I'll set the due date back for this report. This is probably our most involved report, no matter what. And of course, you guys can work together on it. So there isn't much after that. You know, the results are your percent error from the accepted value and your calculated plus minus on your E over M values. And success would be if your plus minus E over M is comparable to the percent error. That means that you did a great job. And I better save this. And in fact, send it to you right away. Lab sections. 1200 charge to message, and this is Phys. Oops, Phys 1200 03 E over M report outline. Okay, and excuse me. Ooh. And let's make a PDF out of this. And I'll post this, but for the people who are here, I can put it into the chat window so you can have it right away. Teaching lab sections 1200. There we go. And as soon as it pops up, oops. And here it is. I'll put it in the chat window. There, and I'll post it. Okay. Any questions? I mean, I kind of plowed ahead because I would hope by this week, by week 8, you guys, or week 7, now I can remember, you guys would have interrupted me if but even so, do you have any questions? All right, what time? Oh, we're still within time. Okay. I could charge ahead and go and do the current analysis. Now, remember too, we want to make our graphs look nicer. We can do things with the number of decimal places. We could certainly want to add axis title. So this is, right, this is the radius squared here. Radius squared. And that's in meters squared. That's right, because we converted it into meters. For example, oops, things like that. You can, and you know, you need the format, make your graphs look nice. Okay. So people are taking off. That's fine. And so what's the current is nice because the sum of the chi-square is greater than 1, which is I would have expected. You have to do a similar thing with the turning the sigma into a vertical error. If you like, I can at least get started over here. Oh, maybe I bet you guys the most important thing would be formulating the chi-square, right? That's the newest thing here. And there it is. So I took the slope. Instead of squaring inside, I squared outside. But that's the biggest difference here. So I took the slope and multiplied it by the plus minus in the 1 over r here, because the plus minus 1 over r is the wiggle here in the x-axis, and I want to turn it into a wiggle in the y-axis for the chi-square. And so I just multiply it by the slope, and then because I need the wiggle squared, I just squared it. So it's the residual squared divided by the plus minus, in this case, the current squared, not the voltage squared. And you see this graph I've jazzed up even some more. I haven't done the plus minus slope on it yet. Let's see if Solver will cooperate again. Data, Solver. So 2 points that I want this to equal, instead of 1.65, I want 2.6526. And I want to, let's just make sure, yeah, it's minimizing. It's working on the chi-square. And it's going to do these two guys. Let's see what happens. Oh, crap, it worked again. Sweet. So this was, I don't know if that got smaller or bigger, but I could just copy it and paste the value. And then I go back to the solver. Wow, I wonder why I could never get this to work before. So we want to minimize it. And then there's our original value. Notice here the percent error was only 1.12%. So then this one's a little bit harder to turn it into a plus minus on the E over M because it's a squared down below. I suppose I should, I'm pretty burnt out right now, so I'll produce a little video of how to do that. In this case, it was pretty easy because the plus minus A here just directly becomes plus minus E over M because there's no error on the 2 or the B squared. But in this case, since the plus minus A, two things, the A is in the denominator and it's being squared, just knowing plus minus A is not enough to know what the plus minus E over M is, but I'll do a derivation for you because I don't expect you to know this stuff. I just want you to see it and to know it in the back of your head, so that one day if you have to face up to this and do it in another class or in your professional lives, that you know what to look up. You know, you can do a Google search for chi-square fits and you go, oh yeah, I remember this. That's what I'm hoping you take away from this. I don't expect you to be able to just do this stuff. You're not like a 2200 student. Okay. Anything else? Any other questions? We're actually still within time, huh? Amazing. And here I thought we'd go home early. Sorry. Although no, I mean, of course, you're not going to complain, right? Until at least after I give you a grade. But all right. So this has been recorded, and you know how to access the raw recording. If I have a chance, I'll take the Zoom recording and chop it up into little YouTube videos. But yeah, I better write a note to myself. I will create a little video about how to take the plus minus slope of the 1 over r fit and turn it into a plus minus E over M. Yep. So let's see, 03, 15, 21. The time is 13:23. Initials. Make video regarding plus minus slope to plus minus E over M for constant voltage data. Okay, got it. I've got it written down. Okay, guys, if there is no other questions, I will say see you later. Is that okay? All right, seems like it. Hope you're not all snoring. And take care, guys. You're welcome. Oh, you're welcome. Thanks
Thank you, Professor.
You're welcome. Thank you. I appreciate it. Very good. See you all soon, guys. Matthew, Myra, and Layla. See you all soon.